Hello dear friends, and welcome to this video in our YouTube channel. In this video friends, we shall be looking at this very interesting question from the Cameroon Northwest Advanced Level mock, the physics paper 2 guys. So friends, we shall be looking at the question 3 guys. We saw question 1, question 2. Now we are looking at question 3, and as soon as this video ends, we shall be looking at question 4 and the entire paper. But friends, you can only have access to all those contents once you subscribe to the channel. And friends, please make sure you share this video out with others so that they can have access to contests like this. Friends, keep in mind that physics is one of those science subjects that keep on tormenting so many students, and the only way you can help your friends is by sharing out this video with them. Thank you very much guys. And friends, please don't forget to like the video. Just simply click on the like button beneath this video. That goes a long way to motivate me. That goes a long way to tell me that you found the contents so useful and you want more contents. And once I see those amount of likes guys, I am going to keep on producing more great content for you guys. Great. So friends, in this video I shall be looking at the overview of this question. I shall be explaining all the concepts involved, all the physics involved. Great. So friends, let's dive straight into it. The question reads that a 100 kilogram mass is released at a point P and it moves along a frictionless track as shown in figure 2 below. The A part is saying that we should state the law of conservation of mechanical energy. The B part, calculate the maximum velocity of the mass. The C part, the net change in potential energy of the mass. Alright. So friends, let's start with the first part, which was also state the law of the conservation of mechanical energy. Alright. So friends, we should know that the question mentioned earlier that this mass moved in a frictionless track, right? That's very important guys. Even if the question did not tell us that it moved in a frictionless path, we are going to assume that it moves in a frictionless path so that we can apply the principle of conservation of mechanical energy, okay? Because it works only when the system is isolated, that is when the system is free from dissipative forces. Because guys, the function of dissipative forces are to reduce the total mechanical energy of the system. In such a case now, the total mechanical energy will not be the same like the total mechanical energy initial will not be the same like the total mechanical energy uh final if the system is not isolated. All right, so for instance, I've indirectly stated the law already. The law simply states that in an isolated system, the total initial mechanical energy equals the total final mechanical energy. Great. That's the law guys. The most important word that you must use here guys is this word isolated. Okay, it the system has to be isolated. That is, it has to be free from dissipative forces. Great. Okay friends, some textbooks are going to say that. There are some textbooks that are going to say this version, which is still the same as this. Some textbooks will tell you that the total mechanical energy in an isolated system is constant. Well guys, this is still true. It is the same as this, okay, but it does not elaborate on what this first law has elaborated. All right, so that's it guys. You can choose either this or either the first or the second, but I prefer you to choose the first. Okay, I prefer the first. All right, the B part is saying that we should calculate the maximum velocity of the mass. Friends, we need to, the question did not tell us where the velocity is going to maximum, but you must have to know the physics that the velocity is going to be maximum when the potential energy is minimum. In other words, where the potential energy is maximum, at that same point the kinetic energy is going to be minimum, and where the kinetic energy is maximum, potential energy at that point is maximum. We should know that the more the kinetic energy, the more the more the velocity. So guys, consequently, we can tell them that but friends, let's get this concept. Okay, let's get this concept. It's super important guys. Let's just get it. It's between you and I. Okay, it's between you and I. So are you ready? Great. So friends, in most cases, if questions like this are being asking you to start by stating a law, there are more chances that you are going to use the law you stated initially to answer the questions that follow. Friends, I didn't say it is a must. I didn't say each time you're being asked to state a law, you must use that law, guys. That is not my point, okay? I'm saying that in most cases, experience has proven that in most cases, okay, in most cases, when you're being asked to state a law, you are likely going to use that law to answer questions on that same question. Okay, great. So guys, we know that from the law of conservation of mechanical energy, which simply states that that the initial mechanical energy has to be something like the final mechanical energy, right? Now, friends, the question wants us to get the maximum velocity of the mass. The velocity in this case, guys, is going to be maximum, like I said initially, where the potential energy is minimum. Guys, you can notice that the potential energy in this case is minimum at this point y, right? It's minimum at the point y, since it is at the zero level. Okay, since the height in this case is zero, so this is where the potential energy is going to be minimum, and as such, at this same point now, guys, the kinetic energy is going to be maximum. So guys, we can simply tell them that at point P, that is the highest level, the potential energy initial at this point plus the kinetic energy initial at this same point has to be the same like the potential energy final, that is at the point y, plus the kinetic energy final at the point y. Good. So we are assuming that the principle of conservation of mechanical energy in this case is satisfied. In fact, guys, it is satisfied because this mass moved in a frictionless track. Wait. So friends, we notice that at the point P, okay, the particle the mass had no speed, okay, it had no velocity. So consequently, it had no kinetic energy. And at this point Y, the mass arrived momentarily at the ground here, right? It arrived momentarily at the ground here. So in other words, guys, the potential energy final at this point has to be zero. That therefore implies, guys, our potential energy at the point P, we know that potential energy is given as what, guys? Mass times gravity times the height, right? Perfect. So we're going to have our mgh plus the kinetic energy at this point, which is zero. That has to be like the potential energy final at this point is zero, at the point y is zero, plus the kinetic energy final, which is equal to 1/2 mv squared. The mass and the mass can cancel, guys. That is to tell you that the maximum speed is independent of the mass of the particle. Great. So if we make v the subject, we are going to have our v to be like the square root of 2gh. But friends, we have involved symbols that we do not know, right? Symbols like v and h. So we must define those symbols. Friends, I am insisting that each time you're answering a question that has to do with physics, make sure you define symbols. It's very important. Make sure you define symbols. If you don't define symbols, guys, the examiner is going to be very mad at you, and you know what can happen when the examiner becomes mad at you, right? Yeah. So we have to define symbols. So we have to tell them that where v is the maximum velocity of the mass or of the particle, then, guys, h is the height from the initial and the final position. Great. In this case, we have taken our final position momentarily to be what? Y. But from the question, this is not the final destination of this our mass. It is rather at the point Q. Great. But we've taken this to be our final position because at this point now, guys, the potential energy at this point is zero. That's why. So friends, if we plug in our values, we're going to have our v to be same like the square root of 2. Our g is 9.81. Then our h is simply going to be the height, okay, at this point, which is 50 meters. So guys, simplifying it so well. And friends, take note. Take special note, guys. Take special note. Okay, take special note. You can see that the question has given you values rounded up, values that have been rounded up to the nearest whole number, right? Great. Or better still, it has given you a value whose highest number of significant figures is 2. So we must respect that fact, okay? We must respect that fact. So if we punch this on a calculator and put answer to the nearest whole number or 2 significant figures, guys, we are going to have our v to be same like 31 meters per second. Your calculator will not give you the same answer exact, okay? It's rather going to give you 31.32 that, but you must have to respect the way in which the question has been presenting the various figures. You have to respect it because on the marking guide, this is what you're going to see. Great. All right, friends. Like I said, don't forget to like the video, friends. Please give it a thumbs up. Give the video thumbs up, guys. Thumbs up, thumbs up, thumbs up, guys. Give the video thumbs up. That is going to motivate me, guys. It is going to help others to locate our content. Great. Thank you very much, guys. Now the C part wants us to find the net change in potential energy of the mass. All right, guys, let's figure out something. Let's figure out something here. We should know that the net change in potential energy, guys, is simply going to be the mass times gravity times the change in height. Okay, keep in mind that the particle started at this point P, right? It slipped and it came back at this point Q. This point Q is virtually not in the same height at this as a point P, right? Good. There's some small change in height, which we can abbreviate it like that, and we can call it our delta H, right? We can call this small height, that is the height from Q up to where the particle started, we can call it delta H. Good. All right, friends. At this point now, you notice that the gravitational force, guys, is what is a conservative force, right? In such a case, the work done by that force does not depend on the path taken. Okay, it does not depend on the path taken, but it rather depends on what the displacement of the particle, that is the shortest distance from the initial to the final point. The shortest distance, guys, is simply this delta H, and that is the delta H that we need to use. You can see that delta H can simply be gotten by what? By taking the difference in distances, right? 50 minus 38. Good. That therefore implies, guys, our change in potential energy, guys, has to be what? The mass of the particle times G times delta H. Delta H, like I said, guys, is simply the change in height. That therefore implies, plugging in everything, guys, we are going to have our M, that is 100 kilograms times 9.8 into delta H is 50 minus 38. So, guys, punching that in the calculator gives us our answer of our change in potential energy to be 11,772 joules. But friends, we must respect significant figures. We must respect, so we can write this guy in standard form as approximately 1.2. Okay, if this sum becomes 1, we can put here we have 2. 1.2 times 10 raised to the power 4 joules. Wait. So friends, that is the answer. Okay, that is the answer. That is it for this question. Friends, please leave your worries in the comment section down below, and I'm going to get back to you as soon as possible. Thank you very much, guys, for watching the video. Thank you so much, and please don't forget to subscribe to the channel. Like the video by simply pressing the like button. Place your comments in the comment section down below. Let me know what you think about the question, what you feel. And guys, shout out and see you in the next video. Thank you and have a blessed day.